The James Webb Space Telescope JWST is widely recognized as the world's most advanced space observatory. Its primary mission, to unravel the mysteries of our own solar system, peer into the atmospheres of distant exoplanets orbiting stars light years away, and shed light on the vast cosmic architecture that shapes our universe and our place within it. In a recent groundbreaking development, scientists used JWST to observe a star located 120 light-years from Earth. What they discovered astonished the astronomical community, compelling evidence of carbon-based molecules in the atmosphere of a potential ocean world, a type of planet vastly different from anything in our solar system. But how was such a discovery even possible? This revelation offers a rare glimpse into an alien world that challenges our understanding of planetary habitability and hints at the possibility of life beyond Earth. Join us as we explore this astonishing find and unpack what it reveals about one of the most intriguing exoplanets ever studied. And if you're passionate about keeping up with the latest cosmic discoveries, don't forget to like, share, subscribe, and tap the notification bell to stay informed. NASA's Game Changer, a new look at K-18 James Webb Space Telescope, has recently set its sights on K-18b, an exoplanet that's about 8.6 times more massive than Earth. What makes this planet truly captivating is JWST's detection of carbon-based compounds, specifically methane and carbon dioxide in its atmosphere. These findings build on earlier observations and reinforce the possibility that K-18b could have conditions conducive to life. Scientists believe that K-18b may have a hydrogen-rich atmosphere and an ocean-covered surface, a combination that's incredibly rare. The first clues about this planet's atmospheric composition came from NASA's Hubble Space Telescope. What is JWST's advanced spectrographic instruments that have taken our understanding to an entirely new level? K-18b is located 120 light-years away in the constellation Leo, orbiting a cool red dwarf star known as K-18. Interestingly, this star and its planet both lie within the system's habitable zone, where temperatures could allow for liquid water, an essential ingredient for life as we know it. A planet unlike any in our solar system, the 18b belongs to a rare class of exoplanets that fall somewhere between the size of Earth and Neptune, sometimes called sub-Neptunes. Our own solar system lacks planets of this type, making K-18b a particularly valuable subject for study. Its unique combination of characteristics, abundant carbon, hydrogen-dominated atmosphere, and signs of water has led astronomers to suggest that it might be capable of supporting some form of life. The presence of methane and carbon dioxide, coupled with a lack of ammonia, supports the theory that a liquid ocean could exist beneath its atmosphere. Even more intriguing, early JWST data hints at the possible presence of dimethyl sulfide DMS, a compound known on Earth to be produced by marine plankton. While the evidence for DMS on K-18b is still weak and requires further confirmation, its potential presence has sparked immense interest. Further JWST observations will help determine whether this biosignature gas is truly present in measurable amounts, something that could change the course of astrobiology forever. Caution and curiosity: is life really there? However, not all scientists are ready to make the leap to declaring K-18b habitable. One astronomer from the University of Cambridge emphasized that while the planet lies in a habitable zone and shows carbon compounds, these factors alone do not guarantee life. K-18b has a radius to 0.6 times larger than Earth's, and researchers suspect it may be encased in a thick, high-pressurized mantle similar to Neptune's structure, beneath which lies an ocean covered by a thin hydrogen atmosphere. While liquid water may exist, the nature of that ocean, whether too deep, too hot, or too rigid, remains uncertain. Nevertheless, scientists have now captured the most detailed spectrum of a habitable zone sub-Neptune ever recorded, using data from starlight passing through the planet's atmosphere during transits. When the planet crosses in front of its host star, they've identified key molecules and gained deeper insights into its environment, the science behind the signal. Transit spectroscopic to 18b is a transiting exoplanet, meaning that its host star briefly dims each time the planet passes in front of it. During these transits, a small amount of starlight filters through the planet's atmosphere before reaching our telescopes. JWST captures this light and breaks it down into a spectral fingerprint, allowing scientists to detect the gases present in the atmosphere with astonishing precision. The research team plans to carry out additional studies using JWST's mid-infrared instrument married to gather more data on the planet's climate, chemistry, and potential habitability. Their ultimate goal? To uncover signs of life beyond K-18b. Discoveries that defy expectations. Wonders don't stop with K-18b. Astronomers using JWST have also detected complex organic molecules, the kind found in smog and smoke in a galaxy that existed when the universe was just 10% of its current age. These aromatic hydrocarbons, which are carbon-based and commonly found in petroleum, coal, and pollution on Earth, were discovered in a galaxy that formed just 1.5 billion years after the Big Bang, composed of dozens or even hundreds of atoms. These molecules are surprisingly large and complex for such an early time in the universe's history. This finding shakes the foundations of modern cosmology. It suggests that complex chemistry may have emerged far earlier than previously thought, raising questions about the rapid evolution of matter in the young universe. A glimpse into the universe's first chapters. Think about it. The light JWST, detected from that ancient galaxy, began its journey over 12 billion years ago. In essence, we are looking back at the first pages of the universe's story, a story that continues to unfold with every new observation. What's most exciting is that JWST has the capability to peer even deeper into time, perhaps revealing even earlier signs of organic chemistry, maybe even closer to the Big Bang itself. In short, the James Webb Space Telescope isn't just a marvel of engineering, it's a time machine, a cosmic microscope, and perhaps our best hope of answering the age-old question, are we alone? If you're as inspired and awestruck by these discoveries as we are, stay tuned. The universe is speaking, and JWST is helping us understand what it's trying to say. These recent discoveries raise profound questions about our understanding of science and cosmology. Until now, efforts to detect complex organic molecules in ancient galaxies have only confirmed their presence. But with the unprecedented resolution of the James Webb Space Telescope JWST, scientists can now investigate not just whether these molecules exist, but exactly where and how they are distributed. One fascinating mystery is the uneven spread of these compounds in the early galaxy SP41847. Despite being only a tenth the age of the Milky Way, this galaxy is already as massive, with stars that have produced carbon and oxygen in quantities comparable to our own. Such revelations challenge existing theories about how quickly galaxies and the elements essential to life can form and evolve. As humanity pushes deeper into the unknown, armed with new technologies and ever-expanding knowledge, we're continually humbled by the scale and complexity of the cosmos. Every scientific breakthrough brings us one step closer to unlocking the secrets written in the stars. With each new discovery, the universe grows just a little brighter. The James Webb Space Telescope continues to redefine our understanding of the cosmos. Its powerful observations are transforming how we study exoplanets, distant galaxies, and the very building blocks of life. JWST allows us to peer farther into space than ever before, revealing mysteries that have eluded generations of scientists. The discovery of complex organic molecules in remote galaxies is just one example of how Webb is reshaping our view of the universe's early stages and its ongoing evolution. Among the most captivating aspects of these findings is the possibility that life, or at least the ingredients for life, may exist in places once thought uninhabitable. For instance, the detection of carbon-based compounds like methane and carbon dioxide in the atmosphere of exoplanets such as K-18b opens new pathways for investigating potential biosignatures. While these molecules are associated with life on Earth, their presence on distant planets doesn't confirm biology, but it does prompt deeper inquiry into whether life-supporting conditions could exist elsewhere. NASA's future missions are poised to dive even further into this question. The Webb Telescope's ability to analyze exoplanetary atmospheres with extraordinary precision represents a monumental leap forward. Scientists can now detect not just simple elements, but complex molecules that may signal the presence of biological processes. This level of detail is vital for evaluating whether distant worlds might be habitable. As our scientific understanding advances, so too does our ability to detect subtle signs of life, whether through atmospheric gases, organic compounds, or other markers of biological activity. The search for life is no longer confined to Earth-like environments. The discovery of extremophiles on Earth, organisms that thrive in boiling hot springs, deep-sea vents, and acidic lakes, has redefined our concept of what life can endure. These findings suggest life could potentially rise in extreme conditions, Elsewhere in the universe. Beyond exoplanet research, JWST is revolutionizing our knowledge of galaxy formation and evolution. By observing some of the universe's earliest galaxies, astronomers are uncovering how stars formed, how elements were dispersed, and what forces drove galactic growth over billions of years. Understanding these dynamics is essential for unraveling the history of our own galaxy, the Milky Way. A striking example is the detection of aromatic hydrocarbons, complex organic molecules in a galaxy that formed billions of years before our own. This discovery underscores just how much we're learning about the universe's infancy and the processes that shape everything we see today. As we continue this cosmic journey, each new discovery brings us closer to answering some of humanity's most enduring questions. Are we alone in the universe? What environments can support life? How did the cosmos come to be? And what lies ahead in its unfolding story? The James Webb Space Telescope is equipping us with the tools to confront some of the most profound questions ever asked, offering an unprecedented glimpse into the most distant corners of space and time. In the years ahead, we can anticipate even more groundbreaking discoveries from JWST. Its ability to investigate the early universe, explore exoplanets, and unravel the fundamental mechanisms that govern the cosmos promises to yield insights that may challenge and redefine our current understanding. The potential for finding new planets, analyzing their atmospheres, and detecting signs of life beyond Earth has never been more within reach. With every observation, we are reminded of the vastness of the unknown and how much more there is to uncover. JWST, with its extraordinary precision and capability, is leading the charge in our pursuit of cosmic knowledge. But it is more than just a scientific instrument. It stands as a powerful symbol of human curiosity and our relentless desire to understand the universe. As we look toward the future, there is no doubt that the discoveries made by the James Webb Space Telescope will continue to inspire, challenge, and expand our view of the cosmos. Whether it's uncovering new exoplanets, probing the structure of ancient galaxies, or potentially identifying life in unexpected places, JWST remains at the forefront of astronomical exploration. Its mission is one of discovery, one that will shape the trajectory of space science and our comprehension of the universe for generations to come.